Okay. Now, so we had just done this problem that says if you've got an exponential, you've got something in the exponent, do the natural log of both sides, work it out. Now, it's especially nice when you have e in there because you have natural log of e, and then that cancels each other out pretty quickly. Now, we ran through a couple others here, like 66, for example, was this. Well, again, do the natural log of both sides. Do the natural log of both sides. And again, this cancels itself out. You get x plus 3 over here. Now, what I did when I showed the work here, I just brought the x plus 3 down in front. ln e is just 1. So you get x plus 3 equals ln 7, subtract 3 from both sides. Right? Same thing. And then on 58 here, said f of x equals 80. And here's f of x. So I just set that equal to 80. You have to divide by the 21st. Then you do the log of both sides, and you go down and solve it. Now, we did have a little bit of a discussion here about how you give your answer with decimals and so forth, and we're going to talk about that when we get into number 64 here. So on 64, we have this. Now, the problem is you have two unknowns. You have a and k that you have to find, but they give you two pieces of information to work with. So what you want to do is you want to just start with one of those and use it. So this one means we plug a 1 in for x, and that should equal 5. So I'm just going to write it on the same line, put a 1 in for x. This would be a e to the k times 1. There's nothing I can do with that, so I'm going to park that up here. I got 5 equals a e to the k. All right? That's it. Okay, can't really do much with that. So now I'm going to go down to this other piece of information they gave me. And I'm going to plug this in. So this tells me I put a 3 in for x, I should equal 10. So a e to the k times 3. Right? Put a 3 in for x, and then that should equal 10. Now I can't really do anything with that either, so I'm going to park that up here. So I got a e to the 3k. Now, what do you do? This is something you learn in algebra. Two equations, two unknowns. Substitution is a big one. Right? Substitution, which means you can solve one of these for one of the unknowns and substitute it into the other one. So if I was doing this problem, I would probably take this first one and divide the e to the k over to the other side. So I'd have a equals 5 over e to the k. Then take that and put it into the other one in place of the a. So that's systems of equations, or two equations, two unknowns. When you have two equations, two unknowns, they give you enough information to write two equations, so then you can do substitution. Okay, which there might be a little faster way. There'd be a couple different ways. Somebody in the other class had an idea that was interesting. They took the top one times 2 on both sides. They took the top one times 2 on both sides, so both were equal to 10. And then they just set those equal to each other. It ends up being the same thing, and it's actually, that was a few more steps, I think, to do it this way. Okay, so I'm going to take this and substitute it in. So I get 10 equals 5 over e to the k times e to the 3k. Now I can put a 1 under that if that makes life a little easier. Now what can I do there? Can I cancel those e to the k's? What would you get? E to the 2k, because really what it is you're subtracting the power. 3k take away k is 2k. So this comes out to be 10 equals 5 e to the 2k. Well, now we can solve for k, just like what we've been doing. So we divide the 5 over there, we get 2, e to the 2 equals e to the 2k. Do the log of both sides. We get ln 2 equals ln e to the 2k. Now you start doing enough of these, and you start realizing when I do the ln of this side, what am I going to get? The exponent, 2 to 2k, right? I do ln e to the 2k. Those two cancel each other out like we were talking about a minute ago. So you can kind of skip some steps here. You start realizing, oh, that's just going to be 2k. Now we divide by 2. Now let me tell you another little thing here that's going to be helpful to you this year. Dividing by a number is usually not a good way to write it. You're better off writing it as a fraction. So like right here, if I'm going to divide both sides by 2, you might think I'll write that ln 2 over 2. You're better off putting that as 1/2 out in front. For a lot of different things we do this year, it's better to write it that way. Also in this problem, it's better to write it that way. So there is K right there, which is one of the things you were supposed to find. Now, how do we find A? How about this one right up here? Let's go right back up to that guy right there, and let's put that back into that equation right there. Okay? So we get A equals 5 over e to the 1/2 ln 2. Okay, now here's where we got to talk about how you would leave this. Now, I will say, one of the things we're going to start on today is we're going to get into the book in chapter 1, and we're going to start focusing on our next quiz. And our next quiz is on, our first quiz, I guess I should say, is on Tuesday of next week. That's the plan. Quiz on Tuesday. Now, a lot of this stuff that we've been reviewing, and I've been telling you we'll do some more trig and stuff, you don't have to be experts at this for this first quiz. Most of what the first quiz is about is stuff that we will start on today, work on Thursday, Friday, review on Monday. Okay? That's most of what the first quiz is. A lot of the stuff we've done up till now is, hey, these are things we're going to see as we go throughout the year. And we want to kind of brush up on them, talk about them, and those kind of things. And the stuff with the door opening and the shading the areas and all that stuff, that's kind of where we're headed. So those things are not going to be on this first quiz. Now, as we go through the next several days, we will see some things that, hey, yeah, we've talked about that already. So we'll see some of those things that are going to be on it. Okay, so I don't expect you to be experts at all of this stuff right here and ready to go on a quiz on it, in 4 days. All right. It's things. Some of these things will pop up though. Okay, so you've got to be ready for it. All right. So anyway, back to this. You could leave this answer like that. They asked for A and K. Those are both answers to A and K because this is just a number here. Now, what will happen later on, like midterm, final, things like that, is this could be a multiple choice question. And this wouldn't be one of the choices. So you've got to be able to rearrange it and do some stuff. Okay, now if this was a calculator problem, you could just type it right into the calculator. Okay, so let's do a couple of things. So let's have Mitchell here be our expert. You guys can all do this on your calculators too. It's good practice. So let's go ahead and type that into the calculator. First of all, let's type in 1/2. Now, a nice way to type 1/2, instead of 0.5, now here's what's going to happen. If he types in a 0.5, if you type in a decimal in your thing, you're going to get a decimal answer because they figure if you typed in a decimal, you probably want a decimal. So erase that 0.5. If you hit Control Divide will give you a fraction. It's a nice way to do a fraction. So let's type a 1/2. And then let's do, and then times ln 2. Arrow to the right so you get out of the denominator. There you go. And then ln 2. And hit enter. Okay? Now, they write it like that. So we'd expect that. Okay, that's good. Here I was telling you to write it with the fraction. They write it with the divide. Whatever. Okay? You understand that's the same thing. All right, now, what did we say about the rules of logs? If you've got a number out in front, what can you do with that? You can move it in. Here's the exponent. What's 2 to the 1/2? Square root of 2. Type in ln square root of 2. Let's see what it does there. Hit enter. Just hit escape. Just hit escape. Okay. See how it gives you the same thing? It does that for you. It takes that 1/2, puts it out there, and so forth. So, back to our work. So, why would we care about that? Because right here, remember when we talked about E and ln are kind of, they undo each other, right? Well, I see an E and an ln together here. I'm thinking, hey, they should undo each other, but that 1/2's in the way. Well, I can get it out of the way by moving it in there. So now this would become 5 over e to the ln square root of 2. Now what's e to the ln square root of 2? Square root of 2. So this whole thing, this whole mess on the bottom actually just turns into square root of 2. Now that would be okay to leave that as your answer, but you guys remember in algebra class you would rationalize this. You take root 2 top and bottom. If you, Mrs. Andreessen and I got a big argument about this yesterday. We were yelling at each other, throwing things. It was ugly. But she said, why wouldn't you do that? Because in algebra, when you're an algebra teacher, that's what you work on. You simplify, you get to here. We let you leave it here. Okay? Maybe it made her mad because she teaches it and then we don't even make you do it. But on that AP test in the multiple choice, this might be the answer. You know, in the multiple choice selections, you get to here, you've got to be able to get to here. Okay, our next quiz on Tuesday, don't worry about it, that's not going to be a big deal. But, you know, we should be able to rearrange and do some of those things right there. Okay, the other example I was showing the guys that were in here when you get pictures taken is this problem. You have ln4 divided by 0.1, you could leave that. But dividing by a tenth is the same as multiplying by 10 ln4. But if you type 10 ln4 in your calculator, it comes out 20 ln2. Well, that's because they thought of the 4 as 2 squared, and they brought the 2 down in front and did it that way. Okay? So just some things to be aware of with logs and exponentials as we go along. All right, let's turn to Appendix G here now, and let's talk about problem number 11. Okay, problem number 11. Now, this is the famous snowmobile or whatever, guy trapped in the snow. Okay, and there's a, what is it, a gas station or something? Or on the left? Well, no, I think it's in east. I think it's in east. So it was 6 miles east of his position, but he's in a field 3 miles south of the highway. So he's down here south of the highway. And the gas station's on the highway 6 miles east of his position. So to me, it would be this. Now, this problem, don't think that all year long we're going to have all these story problems that are hard to set up like one like this. There is a section we do in Chapter 4, part of Chapter 4, where we have some of these types of problems. And we'll practice setting up the various types of problems we run into, where we will have to do this. And it's one of the harder things we do, quite honestly, all year long, I think, is when we get to these problems where we have to set them up. So when you look at this, you think, my God, I never could have come up with that. You know, it's not like that's going to be something that's a daily occurrence. But there is a section where we do these, and it is one of the harder things to do, is setting up these story problems. Okay? Now, they told you that they wanted the time it will take him to get to the gas station in terms of R. So I'm going to use T to stand for time, and in terms of R would mean this. So R is the input of my function. And they want us to write the function. Now, why do we need this in calculus? Well, because in calculus, we will be able to find the minimum time. We'll be able to find the route he should take to get there the fastest. But before we can do that, we have to have a function for the time. So if we can't set up the function, we can't even do the calculus. All right, so what was R supposed to be? On the road, right? On the road. So what are his options? Well, he could go straight there. So R would be 0. He wouldn't be on the road at all. Now, what's the advantage of that? Shortest. But slowest, right? Because he's trudging through the snow. Or he could go up here faster because of the more time spent on the road, where he could walk faster, but it's long. Or he could do something in between. So the question is, which will be fastest? Which one of those will outweigh each other? How far it is or how fast he can walk? So let's just put a line in here that says, okay, let's say he goes to there, and he walks that far on the road. Okay, and then let's call this S for how far he walks in the snow. Okay? So he's going to walk in the snow, and then he's going to walk on the road. All right, now, how do we get time? Well, distance, how about this? Distance equals rate times time. So how do you get time out of that? Yeah, so what we want is the distance divided by the rate. Now, I know there's some other ways around this, some ways you can do it. He goes 4 miles an hour, so you could convert that into 15 minutes per mile, right? Instead of miles per hour, you could convert it into minutes per mile to get how many minutes he would take. And you can do that. As a matter of fact, we're going to talk about number 20, which is all about units, right? So another way to do that, if you go 4 miles per hour, that's 15 minutes per mile. And then you could multiply that by miles, right? So that's kind of an inverted rate, okay? And so you can do 15 minutes per mile times the mile. That's not a bad way to approach this either. Okay, but I'm going to go ahead and stick with this one. So I'm going to take distance divided by rate. Okay, so let's take his distance in the snow first. So that'd be S, and what's his rate in the snow? 3 miles per hour. So this would be S miles divided by miles per hour. So this would give me his hours it's going to take him in the snow. Plus, what's his distance on the road? R divided by 4. Okay, so here I have distance divided by rate, distance divided by rate. Both of those give me time. I add those together, that should give me his total time. Now what's wrong though with leaving this? We got to have it as a function of R. So we can't have an S in there. So we need to get another way of writing that. Ideas? What do you mean solve for S? Okay, in this triangle, right. This right here is going to be 6 minus R. So we can go 3 squared plus 6 minus R squared, and then square root of that, right? Pythagorean theorem. Now we could FOIL that out and everything, but it's not necessary. This is just going to be 9 plus 6 minus R squared. Now do not think, please, I'm sure some of you are thinking it, you don't have to admit it. Some of you are thinking, oh, just square root both of those. You cannot do that. Here's my favorite example to show that. What's the square root of 9 plus 16? What's the square root of 9 plus 16? 5, right? Square root of 25, that is 5. If you square root that and square root that, you get 7. You cannot square root a sum. You cannot square root each of the individual pieces of a sum, okay? So we just have to leave it just like that. So let's take the S off of here, and then we'll put square root of 9 plus 6 minus R quantity squared up there, and there we go. That has to be done before we can do the calculus. The calculus we will do to that. We will take that function and we will find where that function is a minimum. We'll find the shortest amount of time and we'll find exactly where he should walk to get there the fastest. Now, it's kind of a silly example because if I'm freezing in the snow, I'm probably not going to pull out my calculator or my calculus and figure out where I should walk and get there the fastest, right? But it does point out a use that we'll have for it. But if we can't set up the algebra function, then we can't do the calculus, right? So that's number 11. Okay, number 20, quickly here. Number 20 is just shows how when you get one of these story problems, how you can use units to help you figure it out. Now, to be honest, when I wrote this over here, that's another way you could do it. Minutes per mile times miles, right? Think about how you can get your units to cancel to give you the units you want in the end. I can think later in the year, some problems we get into, this is a really key strategy. Take your given information, you probably do this in physics, probably do this in chemistry as well. Okay, so what all do we have? We have $1.50, what is it? $1.50 per, isn't it gallon? Isn't that the cost of the gas? And we have V, which is in miles per hour. V is the velocity. We have a 15 that's what? Dollars per hour, that's the cost of the driver. And we have this 180 minus 2V over 7, and that was what? Miles per gallon. So we want to rent this limousine, and what we're looking for is dollars per mile is what we want to end up with. Or no. Is it dollars per mile or per hour? Cost per mile. So we want to end up with dollars per mile. So let's first take the gas. Okay? The gas, now we want to end up with dollars. So this would be gas and this would be gas. These two over here have to do with the gas. The cost of renting this. Okay? So when I look at this, I look at those two things and I say, well, I want to end up with dollars on top, so I better have dollars on top. And so I want to end up with, so I want to cancel gallons and have miles on the bottom. Well, that's upside down. So what do? Just flip it, right? Flip it. There we go. So this would be 7 gallons over 180 minus 2V miles. And what happens? Gallons cancel gallons. and we get dollars per mile. So that's how much the gas is going to cost us in dollars per mile. All right, then we want to add to that the cost of the driver. Well, he's these other two. Okay, he's $15 per hour. So $15 for 1 hour. And so we want hours to cancel. And we want miles down here. Well, this is going to work out nicely. We got V miles per hour. So where's the V go? On the bottom. V miles per hour. So hours cancel hours. And sure enough, we get that. So $1.50 times 7, I think it's $10.50 over 180 minus 2V plus 15 over V. And this would be cost in terms of V. So what we did is created a function for the cost per mile, and it's in terms of V. Okay, but the way I did that was I just looked at all the given information I had, and I looked at the units I wanted to end up with. And I put them together in such a way that the units would come out the way I wanted. Okay? All right. Well, now that we got everybody back, the good thing is we've had all these disruptions for 5 days, and most of what we've been doing, like I said a minute ago, most of what we've been doing is, long-term kind of stuff, review kind of stuff. These are things we're going to need kind of stuff. And for those of you that just came in, what I said is we're now going to get into chapter 1 in the book, and we're going to start really nailing down here what are the things we need to know for our first quiz, which is going to be next Tuesday. So let's turn in your books back to the very beginning on page 1, and we'll get started there. Okay, so when it comes time to be thinking about what's going to be on our next quiz, now normally I would go around and look at your homework and stuff, but again, a lot of people weren't in here yet or whatever, people coming and going, so we'll probably start that process tomorrow. Like come around, look at your homework at the beginning of the quiz. So all right, starting now, we're talking about what are the things we're going to be doing on our first quiz. Now our first quiz is still really kind of review type stuff. Really calculus starts when we get to section 4. Okay? So section 1 is functions. Section 2 specifically is more about graphs. And section 3 is more about the different types of functions. Polynomials, trig, exponentials, log, but we've already reviewed some of that. Okay? So some of that we should have a running start on. But we'll really be zeroing in on the stuff that you have to know come Tuesday on our first quiz. All right, so on the bottom of page 1, they give you an example of a couple of functions. And this is what we're used to seeing. As a matter of fact, if we go back a couple of screens here, we've got a couple of functions with formulas. That's how we're used to seeing functions. But functions can come a lot of different ways. If you look at the title of your book, the book says Calculus from a graphical, numerical, and symbolic point of view. So we're always looking at functions in a variety of ways. So, yeah, we're going to see functions that look like formulas, like that. But if you read example 1, it says, okay, we're on the Kansas Prairie, we've got a hot air balloon. Turn the page, and you see these two graphs right here. So we have a couple of graphs here that describe this hot air balloon over the Kansas Prairie. Those are functions. You can have equations, you can have graphs, and we're going to see some other ways you can have functions. Okay? Now let's take a look at this. This graph is altitude. So this is feet along here, and this is time down here in minutes. Okay, now picture this balloon. Close your eyes if you want to. Of course, you can't look at the graph and close your eyes at the same time. So look at the graph. Think about this balloon. This is the altitude of the balloon. Now close your eyes and picture the balloon. Okay, now you can open them. Now, how many people pictured this balloon kind of floating along going up and down and like so. Raise your hand. Okay, how many people imagine this balloon just going up and then down, and then up, and then down, staying in one spot? Anybody? Okay, most people, I think, would think of the balloon because they look at this graph and you think of this as the path of the balloon. But now let's look at this graph again. This is the altitude of the balloon at a certain time. So could this balloon just be going up, then down, up, then down? Absolutely, right? This is not the path of the balloon. This is simply the vertical height of the balloon. Now, physics, if you talk about vectors yet, I don't know, horizontal, vertical components and those kind of things, you can get into the path of the balloon and talk about those kind of things, but that gets more difficult. We'll do some of that later. But for right now, we just want to talk about one dimension. So we're just talking about up and down, up and down. Okay? So this is the altitude. All right, over here we have the velocity. Now just the vertical velocity of the balloon, just its up and down speed. All right? Now, one of the things you're going to have to do on the quiz is, let's call this the V graph over here. Let's call this the A graph over here. So if I ask you, some of this on the homework should seem very easy. If I ask you what's A of 4, what would you write? What would you tell me? You would, 4,500? Oh, okay. Yeah, I thought you said 45. 4,500 feet, but 4,500 would be fine. You're just reading off the graph. That's simple. We want to be able to do input, output, be able to read off of the graph. Or if I said this, solve this equation. A of x equals 3,000. What would you say? X equals roughly, approximately 6.1. Now, sometimes off of a graph, the best you can do is approximate. So somebody else might have said 6.2. Here, somebody might have said 4,400, right? Those would have been okay. If you're in the ballpark or reasonably close, that's good enough, okay? What if I just said solve this equation? A of x equals 5,000. What would you say? 0.5 and 2.1, 2.2. You'd have a couple of solutions, right? The output was 5,000. So here I'm asking what the output is. Here I was saying the input is 4. What is the output? So be able to read off of a graph, okay? How about this? Let's look at the two graphs together. What does this point correspond to over on the altitude graph? Which would be this peak, right? Change of direction. Velocity, notice some of them are positive above the x-axis and some of them are negative. Positive velocities mean what direction? Up. Negative means down. So every time this graph's going down, this graph is below the x-axis. Every time this graph's going up, this graph is above the x-axis, right? And so those are going to be some connections we're going to talk about a lot later on. But for right now, we just want to be able to read the graph, some of that. So some of that should seem pretty easy. All right? All right, turn the page. And, well, I'm sorry, down on page 2, still on page 2. So they talk about some of what we were just doing there. Over on page 3, you've got a table of data. That can be a function. Okay? Let's take turn the page to top of page 4. There you've got a function called k. All right? And let's talk about that a minute. So we've got a table of data, and sometimes that's all we've got. If you're doing a science experiment, you collect some data, that might be all you have, or those data points. Okay? So let me ask you this question. What is k of 3? 3? What's k of 2? Oops. K of 2 is 8. What's k of 7? What do you say? Let me put it to you this way. If I give you a function, f of x equals 1 over x, and ask you to find f of 0, what do you say? Now, see, you didn't hesitate at all there. You said undefined. Now, why? Well, you've been trained over the years to know that when you divide by 0, that's called undefined. But what do we really mean by undefined? It has no definition. When you give an equation for a function, you're giving it a definition. When you have a table for a function, that table defines the function. So it defines an input of 3 to be 3. It defines an input of 2 to be 8. So what is k of 7? Good. Undefined. Because the function does not have a definition for an input of 7. So we would say that k of 7 is undefined. So that kind of brings a little new meaning to that term undefined when it comes to functions, because there is no output for 7. Okay? Solve this for me. K of x equals -2. You would write x equals 4, right? K of x equals 100. No. Not undefined. What do you say when you're trying to solve an equation and there is no solution? No. Hey, I gave it away. You say no solution, right? Now this is a technicality, but what we're trying to learn here is the language of functions. That's what we're doing, and this first quiz is a lot about that, the language of functions. So if I ask you to solve k of x equals 100, I'm saying what input gives an output of 100, and there is no such thing. So you would say no solution to that. But see the difference in that. It's not undefined, but it's no solution. No solution. Okay, let's stand up and take a 60-second break. Stretch a little bit. Turn the fan on. It's getting hot in here, isn't it? Stretch, do a jumping jack. I don't know, something. Okay, time's up. All right. Very good. Now, on page 4, you see this graph right here. Now, you're going to want to write this down here, what we're going to do next. Because, and I don't do this very often, but every now and then, I'm now going to tell you one of the questions on the next quiz. Now, I'm not going to tell you exactly the question, but one of the questions is going to be like this. There's going to be a picture of a piecewise function. Now, in the course description questions, and once we kind of get in the swing of things like I think tomorrow, hopefully there won't be something going on. Is everybody gone tomorrow? Please. Okay. Hopefully we'll get a day where everybody's here. Those course description questions, one of the things that people I noticed wrote as something they might struggle with was piecewise functions. Well, I think it's because you just haven't done much with them. You weren't sure what that meant. This is a piecewise function. It's just in pieces. It's got a piece that's a line, and it's got a piece that's a half circle, it's got another piece that's a line, and then a fourth piece that's a line. And all we have to do is write the equation of each of those pieces. Now, a line is an easy equation to do. We've already talked about that. So this is one of those things that we've talked about already that is going to be on this next quiz. And that's his point-slope form. You better be able to do point-slope form of a line. Okay? Because I'm going to give you a graph, pretty much guarantee you there's going to be line segments on it, and there's going to be a part of a circle on it. Okay? So we'll have to review equation of a circle. So there will be a question on the next quiz with a graph similar to this, and it will say, write a formula for this function. Write a formula for this function. So the way a piecewise function looks is we start with a name, f of x or whatever, equals, and then we have some big kind of curly bracket, right, that encloses the different pieces. Now you see it's on page 4 there. You can see down at the bottom page 4 it's got it written. We're going to do it ourselves here, and ours is going to look a little different than what they have. Okay? And so we do each of the pieces. So we start with this first piece, which is a line. Well, all we need to write a line is we need a point and we need the slope. Right? So let's take this first point. That is -5, 3. Right? That's that point right there. And what's the slope of that line? Looks like it's -3/2. Make sure you get the negative in there because it goes down 3 over 2. All right, so now we can write this equation by putting this in. Remember I told you didn't have to simplify the thing and distribute and whatnot. Now, keep in mind that the equation we write y equals this. Well, over here, I've already got my y equals. The f of x equals is already the y equals. So I will just start up top here. I'll put -3/2, parentheses. Now I want to put x minus a -5, so that becomes x plus 5, and then plus 3. Okay, so that's the first part of it. So that's the first little line segment. I wrote the equation of that line using our point-slope form. But now in a piecewise function, I have to tell what piece is that. And so I'm going to put a comma. And now I have to say, all right, that piece goes from here to here. It's like the domain. The domain is the x values, the range is the y value, right? And so I got to tell it that piece goes from -5 to -3. So I'm going to put square bracket, -5, comma, -3. So that tells me, okay, here's this line, which is this first piece, and that piece only goes from -5 to -3. Okay, now the next piece is a circle, and I'm going to leave that to last because that's the hardest piece for us right now. All right, so let's go to the next piece, which is a line. So this piece here. Now this piece, let's just take this point right here, 1, 0. Slope of 1. Okay? All right, so that's going to be, I already got my y equals. I'm going to leave myself a space here for the circle. So I got 1, parentheses, x minus 0. Oh, whoops. X minus 1, isn't it? Yeah. X minus 1 plus 0. And then I'm going to do a you don't have to put the plus 0, but just for emphasis there. Okay? So, and then that goes from where to where? 1 to 3, right there. So from 1 to 3. Okay? Now I'm going to do my last piece. Okay? And let's do this point over here, 5, 0. And what is the slope? -1, right? -1. So I got my y equals here already. -1, parenthesis, x minus 5, parenthesis, and again, plus 0. We do not have to simplify that. On the quiz, it's perfectly fine if you leave your line equations just like that. Then the comma, and that goes from where to where? Now, we can't use the 3 twice, or we can't include the 3 in both of those. It's kind of a technicality. So since I included the 3 here, I'm going to do an open parenthesis on the 3 on this one. But then the 5 I am going to include. Now, it really doesn't matter which one of those 3's I included with a square bracket and didn't include with the open. I could have went either way because it's the same point on both pieces. Sometimes you get a piecewise function that does this. It might come up to here with an open circle and then go here for the next piece. Well, then you have to not include it on this one and you have to include it on that one. Okay? So sometimes it works out that way. But this one, it didn't matter. All right, now we got to do the half circle. So let's go to a new page here. We're going to need a little more space. And All right. So this is an equation you are going to have to know for Tuesday. Okay? So for you guys that are here, and for Jacob Rolla and anybody in the other class who's not here and listening to this on the video, really, today's the first day I've told you something, some stuff that is going to be on the next quiz, right? All the stuff we've done up till now might be on there. We'll find out over the course of the next several days as we go through stuff, right? But now we're getting into some very specific stuff. So yes, you need to know this for that first quiz. Now, H and K are what? Of the circle. This is the equation of a circle. That's the center of the circle, and of course R is the radius. So if we come back to this picture, the center is what? Looks like the center's right there, because it would be 2 to there, 2 to there, 2 down to here, radius 2. Looks like -1, 0 is my center. So our equation would be x plus 1, right, because of the -1, and y minus 0. Now, would you have to put the 0? No, but I'm going to put it as I work through this problem, and the radius is 2. I'm going to put the 0 there because you might get one on the quiz where that was a 3. And I want you to see what it looks like as you go through with that number in there, okay? All right, now, because we have to do more with this, we cannot put this into our piecewise function. Why not? Y equals. We want this to be y equals this. So we have to come back into this, okay? We have to come, there we go. We have to come into here and get y by itself. So I'm going to move that to the other side. So I'm going to get y minus 0 squared equals 4 minus x plus 1 quantity squared. I don't need to FOIL that out. You could if you want to, but we don't need to. We're now going to square root both sides. When we square root it, we get a plus or a minus. Now, we already talked earlier about how when you square root this, you can't square root the 4 and square root the other thing, right? It doesn't work. All right, so a couple of things important there. I'm trying to get the y by itself, and now to get rid of the square on the y parenthesis, I'm going to square root, and when we do that, we have to do plus or minus. Now, we didn't do that on the snow problem because you weren't going to have a negative distance there, so we didn't worry about it. But here, you have to do plus or minus. Now, why is that? Well, we're talking about a circle. Is a circle a function? A circle fails some important test. Remember the vertical blind test? So we're talking about a function. We have the top half of the circle, and we have the bottom half of the circle. That's what the plus and the minus are. The plus here is the top half of the circle, and the negative is the bottom half of the circle. Well, which one do we want? We want the bottom half, so we're going to want the negative one. Now, notice if this would have been something, we're done right now, but if this would have been something other than 0, like a 3, we'd have had to add it over. So it would have looked like this. 0 plus or minus square root 4 minus x plus 1 squared. So we wouldn't have needed to mess with that 0, obviously. And we're going to, you're right. That's right. And we're only going to want the minus. So when I come back over to here, I'm just going to put negative, I'm not going to put the 0 now. Negative, or if it was a 3 minus, whatever. And then square root of, what was it, 4 minus x plus 1 squared. That's what goes in there. But it simply came from the work I did on knowing an equation of a circle. Okay, and then that goes from where to where? -3 to 1. And we always want to go from little to big when we do our intervals. So -3 to 1. And I shouldn't include either one of those because I've already included the -3 and the 1 on those other pieces. Okay? So I didn't include those just because that was the order I did those things, and so whatever. There you go. So there will be a question on the quiz where you have to do that right there. And there's going to be one in your homework where you have to do it, so you'll practice it again. All right? Piecewise function. They're not hard. I mean, the line parts are easy, and it's just writing down the pieces. Just writing down the pieces. Okay. The next thing. go in your book to now to page 6. If you turn over to page 6, partway down, they give some examples of functions. So basically what we've said here is that if you've got functions, they can be an equation, like the f function they give on page 6. It can be described in words, like the human population. It could be a piecewise function, like we just saw. It could be a graph. It could be a table, right? You can be given a function in a variety of ways. All right, every function has a rule, a recipe that gives its outputs. It might be the table, it might be the graph, it might be a formula. Okay? You have domain and range. Domain and range are the x and the y values. Okay? So if we take a function, oh, there's my schedule coming up. I have a lot going on. All right, if you take a function like the sine function, okay, what's its domain? It's usually best to think of a graph whenever you're wanting to do all reals, right? The domain is all of the different x values that you can plug in and get out a y value. Well, you can plug in any number you want from negative infinity to infinity. Now, when we say all reals, you can write out all reals, or you can actually write negative infinity to infinity. Now, whenever you put infinity, you would not want to put a square bracket. Right? Doesn't make sense. You cannot include infinity. So it's got to have an open parenthesis. And they would take off for that on the AP test, for sure. Okay? What about range? -1 to 1, and those would have to include the endpoints. Now, your book does something that I think is kind of interesting, because I think range is a hard thing to do sometimes, harder than domain. And it's what the outputs are, but they give an interesting way of thinking about it. If you look at the picture on page 8, they say if you think about a light, to do range, if you think about a light shining from the left and shining from the right, the range is the shadow that would be on the y-axis. In other words, the graph would block the light. So if I think of a light shining, it would be blocked when it hits the graph. And it would leave a shadow on the y-axis from here to here. So if you have any difficulty thinking about domain and range, especially range, that might be a way that's helpful to think about. -1 to 1. Now, we don't want to write 1 to -1. We always want to go little to big when we write these. Okay, let's go back to this other picture we had a minute ago. What would be the domain on this one? Domain would be -5 to 5, right? And hang on here, so I have one right. There we go. -5 to 5. And the range would be -2 to 3. Shine a light, it would get blocked by the graph, shadow on the y-axis all the way down to there, which is from -2 to 3. -2 to 3, right? Even though the light would go through here, it would get blocked on this side, right? And so the y values go from -2 up to 3. That is the range, all right? What if you had a table? This is my last comment that you start working. If you turn back one page, the bottom of page 6, there's a table, the K function. I said, what's the domain? What would you say? Well, you wouldn't want to say -3 to 4. You would want to list them, but yeah, because -3 to 4 would include all the points in between. -3, comma, -2, comma, -1, comma, 0, comma, 1, comma, 2, like that. And the range would be the same thing. You would actually just write a list of those values. Now, if some of the range values repeated, you wouldn't have to write them down more than one, right? But that's how you do it with a table, domain and range. Okay, so the homework is on the homework sheet 1.1, okay? The 1.1 pages 8 through 10. Do those problems. A lot of them are just about functions. They just have to do with domain and range and outputs and reading a function notation as you go through it. If it seems pretty easy, that's a good thing. probably should. However, some of what we're doing with functions is a little bit different than what you've done before and haven't done it for a while, so it may trip you up, some of the language. But it's just about the language of functions. But if you're looking at a problem, you're saying, really, all they want me to do is read the graph and write the y value? Yeah,